right, welcome back everyone. We're going to move on to Division 2, existing conditions. And once again, the divisions are from the master format, and our book follows right along with that. And so this would correspond to book chapter number 2, and in particular sections 2.1 and 2.2. So with that in mind, let's start by looking at land surveys and a little bit about different methods and what that looks like. So the first thing we should do is define what we mean by a land survey. And a land survey is basically going to be the legal description of our property. And this will be spelled out typically within the project manual from what we talked about last time. So when we talk about these land surveys, what we're going to discuss here are really three different types of surveys. The first being a Metz and bounds, the second a rectangular survey, and the last a plat, also called plat maps. And basically what these things are is, and we'll talk more about this in just a little bit here, but they're already recorded. It's a recorded map of layout, property lines, things like that are on file at some location. So let's take a look at each one of these individually, starting with the first one with this Metz and bounds. And the way these Metz and bounds work is you're going to map out your property, and you're going to be starting at some location that is already known, or some known point. And this known point where we're starting is called a POB, and that stands for the point of beginning, since that's where we're beginning our plot. And after we have that beginning point, we're going to map out our property by using a series of angles and distances. So looking at a quick little example, a very simple example. Say I wanted to start at our point of beginning, and we're going to call this our point of beginning right there, so POB, and let's say our property looks something like this. Say it went up over to here, and then maybe down to there somewhere, and then over here and over here. Don't break out your protractors, because I'm sure this is just estimating, give you an idea of what it would look like. But let's say that's our property. Now, in order to be able to locate these points, what we give are distances and angles. So I might know that this is 180 feet to get from our point of beginning up to this first little turn within the property, right? But then I need to designate the direction that I'm going as well, other than the length. And the way I do that is I can look at a direction, and we're using our coordinate north, south, east, west, with, in this case, what I'm saying is north is going straight up. And let's say that this angle in here were 50 degrees from that north coordinate. And if we're going to do that, then the way we would label this on our plot here is we would say, well, we're north 50 degrees east. And basically what that's saying is from north, we want to rotate 50 degrees to the east, and that's the direction we'll be going for 180 feet. And continuing with the same process, for my next turn, let's say that I knew that this length of this segment was 280 feet, and then angle-wise, I wouldn't want to go all the way from the north again because it's greater than 90 degrees. Instead, I would come up from the south, and let's say this is 45 degrees. So if I did that, same idea, but now I'm saying, well, I'm starting from the south, we're going to go 45 degrees in the easterly direction. So that gives us our angle. And we go 280 feet until we get to our next little turn here. And let's say that in this case, we're going to be 70 degrees, and we'll say that this length is 220 feet. So see if you can think about what that would look like. What is it going to be? What south? What 70? What east? What north? What west? What does it look like? So what it is we're starting from the south direction, and we're rotating 70 degrees towards the west. And then our last one. Now the last one, like I said, I wanted an easy example, but it is true that I have to close it up. The whole thing has to close. So in that case, I had to get a little more particular here. So this last segment, in order to close up, it would be 203.7 feet. And angle-wise, you'll just have to take my word for. Well, I guess I could show it on here, right? But the angle, what was I doing? I was doing a blue line, green angle. So this angle in here, in order to make it close, what it needs to be is 39 degrees, 20 minutes, and 42 seconds. And so if you've seen this before, of course, there's 60 seconds in a minute, and there's 60 minutes in a degree, so you could break that into decimal form if you wanted to. But we're not gonna get into the weeds on some of that stuff. Instead, what we'd want to know is if this is our north direction. So we're saying from the north direction. See if I can fit this in here. I would have 39 degrees, 20 minutes, 42 seconds, and that's from moving west from that north direction, right? So, so that's an example of meets and bounds, a pretty basic example. I will make a note. Remember, I had to make that thing close up. So if you might want to make a little note of that it should end back at your point of beginning, or it closes up, right? So this was the first real system that was used, and they used their point of beginning to be like a landmark. It would be like a big oak tree or something, right? Or a stub, you know. Or so the problem with that method, of course, is it's dependent on that point of beginning, and that can get a little bit hazy at times, at least back in the early days. So at some point later, we decided to come up with more of a international system to map out exactly where everything is located. And this is what we're calling the second method, which is our rectangular survey method. Now, another way you'll hear this, or another AKA, means also known as public land survey system. And that'd be abbreviated PLSS. Now, of course, as you can tell from the definition, it is a rectangular. What this is based on is a grid type system. And this is the most prevalent, used even today, and because of that, I'm definitely going to spend the most time on it. And but let's start with the idea of a grid. If I were to think of a grid, something like this, to map out exactly where everything's going. Now, with this grid system, we have vertical lines and horizontal lines. Now, these vertical lines, this is using that same coordinate system where north is up, south is down, so on and so forth. Now, these vertical lines, what we are calling those are the meridians of longitude. And these horizontal lines, we're calling the parallels of latitude. Now, probably at some point you've heard latitude and longitude, and hopefully you remember that latitude is that horizontal east-west direction, and the meridians, or longitude direction, is our north-south. It seems like there'd be some easy way to remember that. I don't know. I think it's always like, oh, latitude, and some people realize that means like it's wide. I don't know. I never really had a good way to remember it, but longitude vertically, latitude horizontally. So with that in mind, the issue that we come across is this is a rectangular system, and we're using it to map out on a globe, which is a spherical object. And so if we were to look at this on the Earth, let me move this down just a little bit. For my latitude lines, I could think of one line, and this is always so hard to draw 3D in a 2D plane, but that's like our equator. And on the equator, that's our 0 degree latitude. So let me jot that down so we don't forget what we're talking about here. And then it's working its way up or down based on degrees. So the next line up here would be like the 15 degree latitude, and then 30 degree, 45 degree, 60 degree, and at the very top, right by the North Pole, would be your 75 degree latitude. And of course it does the same thing going to the south. So we would have, and I'm not going to probably bother to label all these, but 15, 30 degrees south latitude, you know, so on and so forth. And it's the same idea with our longitude, but now we're talking about vertical lines. So we'd have one line right down the middle as I'm looking at it, and this is what I'm considering my 0 degree, and we call this our prime meridian, and this does happen to go through Greenwich, England. And I hope I spelled that right. I don't have it in front of me. I think it's Greenwich. I think there's a W in here actually, isn't there? Ah, well, not that important. And then as we're moving to the left or right, just like before, we're going to be changing by degrees. So I'd have something like this, and in the same way, our first one over would be 15 degrees, and then 30 degrees, and 45 degrees, so on and so forth, and same idea with the other way. So that's our latitudes and longitudes in a nutshell. Now, here's the overall issue, is that if we're talking about a rectangle, or a square, a gridded system, we're trying to put it on a spherical shape, then we know there's going to be issues with keeping our lines. They can't be parallel forever, right? So here's a picture that I stole from somewhere, and so this would be the primary issue with this system, is that we have these longitudinal lines, but they clearly cannot be parallel forever. They start out parallel and they start to merge because they have to merge at the two poles, right? Down here is our equator where we're furthest apart. So there is our primary issue. We have a rectangular system we're trying to map out on a round Earth. So things are going to be skewed. And we don't want our lines to be constantly changing because that would make it much more difficult to map things out. So instead, for a solution to this problem, we will have some correction lines. And these correction lines occur every 24 miles, both north and south and east and west. Now, if you're to look at our gridded system, we have our latitudes going horizontally, and then let's say that this was 24 miles between each set of lines. What I see is I might have a certain spacing between these guys, and then as I go up, things are going to shift to try and fix these correction lines, right? And so yeah, so we'll see an example of that in a little bit. So if we were to map out this system on the entire U.S., here's a map of the U.S., we can see some principal lines that we are going to map off of. And in particular, what we'd be concerned with in Colorado is this one solid black line that's going through Kansas here. This is what we're going to call our baseline. That's the baseline that we use. It goes right through Boulder. If you've been down to Boulder before, there's a road that's called Baseline, and that is on the baseline. So, and then we also have so that's our latitudinal line that we can measure off of. Now we also need our longitudinal line to measure off of in Colorado. We're going to use the 6th prime meridian, which is this guy right, well, let me just draw on here. It's this guy right there. So we have our 6th prime meridian, and we have our baseline, and that's going to be like our fundamental point. So if we are measuring something, say up here in Fort Collins somewhere, that's what we're going to be basing it on from the from the left or to the west of the 6th prime meridian and to the north of baseline. We'll see more examples of that too. But that's our primary base location to start all of our measurements. Now the problem is that that these grids end up being fairly big, and we want to get more particular, right? Because we were just talking about every 24 miles there's a correction line. So if I'm starting with a grid of 24 miles, it's going to be hard to really map anything out. So what we want to look at is how we can subdivide our grid into smaller pieces. So we're starting off with the 24 square miles. We're going to divide that into townships is going to be our little designated subdivision. And we're starting off with 24 by 24, and our townships will be 6 miles by 6 miles. So if I were to draw this in a grid, it would look something like this, where each one of these is 6 miles. Now, we have to label these so we can figure out what we're talking about. And the first thing we would say is these vertical lines here, we're going to call these our township lines. So the township lines, as you can see, all run north to south. And horizontally, this road I've drawn in green, we're going to call our range lines. So of course those range lines run east to west, or west to east, doesn't really matter. Now if I wanted to talk about a particular segment in here, like say I was looking at this plot right in here, well, I can say that this is in Township 2 North, Range 3 East. And what that means is if I, from this bottom line, since ranges are going east and west, how far do I have to go up? Up on the second. This would be like my first, row up, but I'm not in that row. I'm actually in the second row up, so that's where my range, Township 2 North, sorry, and the range, moving east to west, I can see it's 3 east. So along my range lines, I have to go 3 townships over in essence, right? So that's kind of how I'd label it. And in essence, here's what we just did. What we did is we divided 24 square miles into 6. And once again, these are called townships. Now the issue would be, well, we have a 6 square mile grid, but that's still a big section, right? So I want to subdivide that's into smaller pieces, which we're going to call sections. And what I'm going to break it into are 1 by 1 mile. So I end up with something like that, where I have a whole bunch of 1 by 1 mile squares. So in summary, what I did, I divided 6 square miles into 1 square miles, and these are called sections. So we took our township, divided it into sections, and now we're going to start labeling it. Instead of before where we had a distance from our township line and our range lines, instead we're going to number each cell within here. And the way the numbering works is it's going to start in the upper right hand corner, and that would be like area 1, right? And the way the numbering is going to work is we're going to move from right to left sequentially. Now when I get to the end, instead of going all the way over and starting with the next row, I'm just going to go straight down and then back, and I'm going to make this zigzag pattern until I have all of these labeled. And I should end up with 36 different plots of land, each one 1 mile by 1 mile. And then one other thing I want to note is that each section then actually is based on an overall land of 640 acres. And that ends up being more important than the 1 by 1 designation. So each section is 640 acres. Now, just like before, 1 mile by 1 mile is a big plot of land. So we need to divide that. Again, now we're going to divide our sections into subsections. So looking at this and starting with our 1 mile by 1 mile, what I can do is I can divide it in several different ways. I could divide it into a half section. So I might be looking at something like that. I could divide it into quarter section. Of course, now we're saying something like that. And I could divide it into a quarter of a quarter section. So that would be something like this. If we divided that into a quarter. And of course you can just label it from north, south, east, and west. So if I were looking at quarters, this would be my northeast quarter section, southeast quarter section. And if I wanted to subdivide that, like say I was looking at this little cell right there, I would call this the southwest quarter section of the northwest section. So you're starting off with the smaller area, meaning like the smaller, I'm not going to look at this whole quarter as the first part of this designation. Instead, I'm starting with the smallest little bit, this little bit. Well, if I say, what is this? This is in the southwest corner of this. Well, what is that? Well, that is the northwest section of this 1 by 1 section, right? So, and you can further subdivide, and I know it gets kind of crazy because now when you're putting the whole thing together, you know, you're saying the southwest quarter section of the northwest section of section number 12, township number, you know, whatever it is, and you can work your way around. So I know that was a lot, and because of that, I think that we should look at a quick example by trying to map out our Guggenheim building. So I have a link here, and if I were to click on this link, this is an ArcGIS of Colorado. Hopefully it's loading. There it is. So this is Colorado, and you can see this grid system. What we're most concerned with is Fort Collins. So as I zoom in, make sure I don't zoom in too far, it's all interactive. And what I'm really looking at is the lines of latitude and meridian. So I don't see anything yet, so I keep zooming in, and pretty soon, there we go, I start to see, let's see if I can write on here. I don't know if it's going to let me, oh, it's not going to let me write on here. So I can see right there, we are in Fort Collins. We are in the 7 north, 69 west. So what does that mean? That's 7 latitudes north of baseline, 69 meridians west of the principal, right? Now, if I were to keep zooming in on there, sooner or later, it'll grid out again automatically for me. There it goes. And what we would want to do is we wanted to say, what? Well, I went in a little too far. Let me go back just a little bit, see if I, there we go. So now I'm seeing numbers, and I'm looking for, you know, here's Colorado State University. Can you see it? So it looks like 14 is centered right on there. So that means we are in section 14, and I can continue to zoom in on this. Maybe, there we go, and let's see, there's the oval over here. So you can see that's in the southeast, northeast quarter, and you can still make out these darker lines over here. So we can see that is the quarter of that section. So if we were to, let me see if I can get back to my OneNote without killing anything. So if we were to map all this out, you know, we're in the township, you know, 7N, 7 north, range 69 west. That was the first thing that we saw. Then we're in the section 14. The quarter is the northeast quarter. And then we have quarter is the southeast, quarter, northwest, quarter, northeast. Now, I'm not going to make you do anything quite like that, not specific on like an exam or something, but it is important to understand the way it's labeled. And I mentioned this earlier, that it's going from smallest to largest. So as we move down, what we're saying is, you know, we're starting out way zoomed out with the township, then zooming into section, and then going into quarters and so on and so forth. Well, that is moving the opposite direction over here, meaning we're starting with the smallest, northeast 1 quarter, within the northwest 1 quarter, within the southeast 1 quarter, so on and so forth. So take a look at that, play with the link. It's kind of fun to play with. You could map out some other places, but what you really need to be responsible for is just understanding the process that it is, you know, the subsections are housed within these sections. Sections are in townships. Townships are within our whole rectangular system, or PLSS. So, all right, that was all with that rectangular system. So the last system is called the plat maps. And plat maps, by the way, this also is known as, AKA, lot and block. And the reason it's sometimes called that is because really what this usually is it's usually for some kind of subdivision, residential construction, something like that. So once you say you were a developer and you're developing a whole plot of land, you might come up with this plat map stating like the different property parcels. And this would be an example. I don't want to spend too much time on here. You could go here. This is Fort Collins. You could click on one of these guys. I clicked on South Taft Hill. This is actually right by my house, so I thought that was interesting. So I clicked on this one. Now you know where I live. I'm gonna come TP me or something, right? But you can see that within Fort Collins, what we have here are these. This is 225 South Taft Hill. This is 245. Now those are physical addresses, but you can see these are all plotted out as land. Sometimes they'll be more numbered, like, you know, lot 15 or lot 16 or something like that. Also notice you do have some other descriptors that might look a little familiar, where we're saying, you know, beginning at a point 640, well, this is kind of interesting, I didn't think about this, but beginning at a point 647 feet north in the southeast corner, so that would be our point of beginning, right? Then we move north at 89 degrees, 35.5, and west 246 feet. So we have a direction, and we have a distance. So now we're talking about meets and bounds. So that's kind of cool. That was actually the last topic I was going to talk about here. If I can get back over here. And that is the fact that sometimes there may be a combination of surveys used to describe a piece of property. So for example, if I were to look at this, and read through this, and granted this sounds kind of lawyer-esque, but we have a tract of land in the southwest quarter of section 30, township north, range 66. So you start hearing these things and these words sound familiar, right? Township, ranges. We're talking about the rectangular coordinate system. And that goes all the way down to right there. So this is all of our rectangular survey system. But after we get there and you start reading, we have beginning at the southwest corner said to be section 30, considering south line, blah, 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 blah. Now we're saying that we're going to bear south 90 degrees, 0 minutes, 0 seconds west. And, whoa, and it'll have directions, and it also has distances in here, right? So because of that, this whole second section would be meets and bounds. So sometimes, just like on that last little example we looked at with the plat map, you'll have a combination of land surveys. So the only other thing that I need to talk about is, it's a pretty easy concept, but it just got smashed into this section. It doesn't seem to belong with surveys at all. That's okay. And that is this idea of demolition and excavation. And really, you've probably been somewhat exposed to these words before. So when we talk about demolition, then we're talking about removal of the land features. And this could include buildings or other removal of whatever else it might be on that land. But the key is that this is all happening above grade. Grade being the ground level, right? Versus excavation, still removing of everything that's in your way, but this is below grade. So just make sure you don't screw up those two words. If I look at a building and I needed to remove this building because it was in my way for whatever reason, then any of the removal of stuff above, this would be my grade line, right? This is where the ground is level, or the ground is. This would be our demolition, and going below grade would be excavation. So that's all I have for this one. Now, this was a departure from the normal PowerPoint method and our mode of education. Instead, we're doing more of a writing things down, drawing pictures. What did you think? Did you prefer this? Did you prefer the old PowerPoint? Let me know. I'm open to covering this content, whatever is best to meet your needs. So let me know if you have any questions or comments, and I'll talk to you all later. Thanks.